Hi everyone! Alright, so in this video I'm going to show you how to find the Taylor series of sine, cosine, and exponential. And so the Taylor series has a derivative in it, right, in the formula. And so the derivative of sine, cosine, exponential are usually repeats, like it goes back and forth. And so there's already a formula that you could just memorize that applies to every sine, cosine, and exponential. So the Taylor series for sine equals the sum from n equals 0 to infinity of minus 1 n to the x 2n plus 1 all over 2n plus 1 factorial. And for cosine equals the sum, oh, that was ugly. Okay. The sum, okay, n equals 0. That does not look like a sum. Okay. There we go. To infinity of minus 1 n to the x 2n all over 2n, and that's factorial. And for exponential, it's e to the x summation n equals 0 to infinity of 1 over n factorial. Oh, that's an n, not an h. N factorial times x to the nth power. That, my n's are ugly. Okay, that's better. Okay. So you have these formulas. And so with these formulas, you have a couple of shortcuts to find more complex Taylor series using these as your basis. And so there's 3 shortcuts. Shortcuts, because everyone loves a shortcut. The first one is you can just multiply series. So if I have sine times cosine, I could just have their Taylor series multiply each other. All right. Next one is substitution. Substitution. Spelling is hard. Where, say I have, let me do an example. Let me write my example for this one. Sine x times cosine x. Ooh. It's just their summations multiplied with each other. And then, say I have e to the minus x squared. This is just the Taylor series for e of x with x squared plugged in. This is positive x. Positive x squared. So I'll just be like n equals 0 of 1 to the n factorial of x squared times n. Because that's the original formula for e to the x. And you could integrate it. Integration. So right now I'm going to do an example for, let me highlight it, multiplying series and for integration. I think substitution is self-explanatory. Okay. So let's start off with example on multiplying series. Okay, we're going to find the fifth order Taylor series of, let me see my notes, f of x equals e to the x cosine x. So, first off, it's e to the x times cosine x. So like I said before, you could just take the two Taylor series and multiply it together. So for e to the x, it's 1 plus x squared over 2 plus, x cubed over 3 factorial, just to keep the pattern, plus x to the 4 to the 4 factorial plus x to the 5 to the 5 factorial times the Taylor series for cosine x. Ooh, is this going to fit? 1 minus x squared all over 2 factorial plus x4 over... Ooh, that's an ugly 4. God, okay, we're doing good. 4 factorial. And so I stopped at the exponent 5, and then for the cosine, there is no exponent 5. The next one would be x to the 6. And so from here, you'll expand it. I'm going to leave that as an exercise to the reader and just skip to the simplified version, which is 1 plus x minus x cubed 3 minus x4 over 6 minus x fifth to the over 30. And that's t to the 5th. Oh, God. What was that? Okay, let me scroll up a little. T to the 5th x. And so the question was find the 5th order, which means find the Taylor series up to the exponent 5. Yeah. Okay, so pretty simple, just multiplying it. Okay, next example, I'm going to do... Oh, God. Okay, example. Let's do an example of integration. How do you spell it? Integration. Yeah, that's how you spell it. Okay. So I give you a formula. Oh, that's ugly too. J equals the integral of 0 to 1 of sine, oh God, x squared dx. And I want you to expand that. Let's start off with expanding what's inside the integral. Sine x squared. And this is a substitution rule too. So that's the summation of n equals 0 to infinity of minus 1 n all over 2n plus 1 factorial times x to the 4n plus 2. Okay. Now we're going to take this and put it back in the integral. So it'll be j equals, oh, that's an ugly j. J equals the integral from 0 to 1 of sine x. Yeah, let me just write it out so it'll be easier. Sine x squared dx. And so from here, we'll just plug in what we find for sine x squared. So it's the sum of n equals 0 to infinity of minus 1 n 2n plus 1 factorial of x to the 4n plus 2 dx. Okay, let me scroll up a little. Let me scroll down a little. Okay. This is simply apply the integration rules. Oh, this is to 1. This is a 1. Okay. So, let me highlight it. This first part has nothing to do with the integral because it's an integral with respect to the variable x, and that has no x. The only part that has an x is, this part. So we apply the integral to just this part. So it'll be the sum to infinity of minus 1 2n all over 2n plus 1. Ooh, I'm a little crowded here. The integral of 0 to 1 of x to 4n plus 2 dx. And so, let me highlight it. This part right here still has to stay inside the summation. Because there's still an n right there in the exponent. So it can't go outside the summation. And so you can, this is just simply doing the integral with that on this function. And that equals the summation of 0 to n equals 0 of minus 1 n to n plus 1 of 1 all over 4n plus 3. Yeah, there you go. So that's a couple of shortcuts to find this Taylor series of functions you already know. So yeah, so it's very useful if you can memorize these three. So you don't have to go through the whole process of how we did it before in the previous video. All right, that's it. Thanks for watching.